Hello, let's do a bit of integral review. I think that the most important thing to know about integrals is deciding what you need to look for in the integral to decide which technique to apply. So that's what we're going to talk about now. First, you should just look to see whether or not you actually need anything tricky. So a lot of these, it's just going to be like a basic power rule. So this number 1, for example. Or number 2, if you just rewrote it a little bit. So this is x to the 1/2, and this is x to the -2. So in this case, some simple rewriting would let you apply the power rule. So that's the first thing to look at. Right now, take a minute and sort of scan down and try and identify what are the other problems where you don't need any special tricks. Like a little bit of algebra will let you turn it into an integral that's a basic integral that you already know. All right, I've zoomed out a little bit, and I've marked all the ones that I think are basic. So this one, for example, you can simplify it to be just e to the 6x. This one, the natural log, and the e will cancel each other, although you have to keep in mind the domain restriction for this one. And then these are also basic. So for the other ones, we've got a couple of techniques. We've got substitution, we've got integrating by parts, we've got integrating by partial fractions. So I'm not going to reteach those techniques in this video. You can look for other videos for that. But I just wanted to point out what should you be looking for to decide whether or not a technique applies. So for substitution, the whole idea is you have some function that's inside another one, and the derivative of the inner function is also present in the integral. So for example, it's going to look something like sum complicated to the function to the 5th power, and then the integral is also present. So for example, you could have like sine x to the 5th times the derivative of sine, so that would be cosine. So if you see something like that, or you could have sine of something like, I don't know, 10x cubed plus x, and then the derivative of that, so 30x squared plus 1. So anything where you notice that there's an inner function and that the derivative of the inner function is present, that's going to be substitution. Just skim down right now and identify which of these are obviously substitution, and then there's at least one that's substitution, but it's a little bit less obvious. So I've marked all of these as pretty obviously substitution. So we've got 3, 5, 6, 7, and 9. A couple of words about that. So I said that the derivative of the inner function is present. So let's just look at this one. Here the inner function is x to the 4th minus 10. So the derivative of the inner function would be 4x cubed, and then the minus 10 is a constant, so its derivative is 0. And you might say, hold on, it's only x cubed that's present. So the full derivative of the inner function isn't present. And that's an easy situation to fix algebraically. So if I wanted, instead of x cubed, if I wanted the full derivative to be present, I could just put in a 4. Of course, that's changed the value of this integral, and I don't want to do that. So I'd put a 1/4 on the outside. So 1/4 times 4, that's just 1. So I haven't actually changed the value. But now you see that the entire derivative on the inside is present, and so I could apply substitution. So really, you shouldn't be looking to see if if the derivative of the inner function is present. You want to look to see, is a constant multiple of the inner function's derivative present? So for this one, the inner function is x squared, and the derivative of that is 2x, and that's definitely constant multiple away from x. For this one, here there's a couple of choices for your inner function. You could have like cosine cubed be the whole inner function of the 1/x function, but that doesn't actually work out because the derivative of cosine cubed isn't there. However, I noticed that sine is the derivative of cosine, so we could make just cosine be the inner function. So we could rewrite this as like 1/something cubed, cosine's the blob, and then we've got the derivative of blob, which is sine x, is present up there. This one, you have to be able to do this in your head. You have to be able to see 1/x as the same thing as x to the -1. And then the derivative of x to the -1 is negative x to the -2, which is the same thing as this. So these You may not look at these and see the inner function, but you got to be able to do that. And then last but not least, this is 1 over blob, and because blob is natural log, the derivative of natural log is 1 over x, and so this would be the derivative of blob. So you see that, again, matches the pattern. Okay, let's talk about integrating by parts and by partial fractions. So integrating by parts, the whole idea is you can take whatever your integral is and divide it into 2 pieces. And one of the pieces you're going to take the integral of, and the other piece you're going to take the derivative of. So you should look and ask yourself, can you completely exhaust the entire integrand here into 2 pieces, one of which you know the integral for and one of which you know the derivative for? Partial fractions is usually a situation where you have sort of a rational function. So f and g are both polynomials, with f a smaller degree than g, so it could be like a constant over some linear terms, or it could be a linear term over, and these could be linear terms, or they could be quadratic terms, but something like that. And the idea, remember, is that you're going to decompose this into several integrals where it's going to be like a over one of your terms and b over the other of your terms. The thing to be, and then of course these are integrals. The thing to be careful of here is you want to double check to see whether or not it's not going to be easier to do by substitution, or whether or not you can't simplify it before you start, so that way you don't actually need to decompose into partial fractions. So look back at your list here and now decide which ones do you think you can do with integration by parts and which by partial fractions. So the ones I've identified, this can be rewritten as the integral of 1 over x times x plus 1, so that can be decomposed by partial fractions. This one, you can also factor the denominator, so this one can be decomposed into partial fractions. This one can be done by parts, because we know the derivative of 3x and we know the integral of sine x, so that's going to be pretty straightforward. And then there's a couple that we haven't marked yet, because they weren't obviously one thing or another. So we've got this tangent, and we've got this thing. Tangent, you might think, okay, I know the integral of that. It's secant squared. Nope, that's wrong. It's the derivative of tangent that's secant squared. The integral of tangent, you probably don't know. So my advice when you're not sure is try to massage it a little bit algebraically. Work with it a little bit. So instead of tangent, what if I rewrote that as sine over cosine? And now think about what might apply. Is it a basic one? Is it substitution? Is it by parts? Is it partial fractions? For this one, let's see how we can massage it a little bit. I just want to change its form. The whole idea is you want to make it look differently so that way maybe you'll see whether or not a rule applies. So I'm going to try and rewrite this in a slightly different form by splitting it into 2 separate fractions. So here I've got e to the 4x divided by e to the x, which is e to the 3x. And then here I've got minus 1 over e to the x. So again, think about this one. Which of your rules might apply for this one? Okay, good luck!